Hello everyone, welcome to AI Anytime channel. In this video, we are going to develop an application called Pet Care AI. So it's going to be a chatbot or also a search application where you can, search for a query and you can retrieve some kind of information related to the pet care. Okay. So this is going to be helpful for veterinaries, doctors and pet lovers. So we're going to take couple of data sources, one of them being the case studies, for pets, and the other one is the encyclopedia for dogs. Okay, so this is what we are going to take as a data source, and we are going to build this application called Pet Care AI, where we are going to use the open source large language model called Llama 2, and of course we are going to combine that with LangChain and couple of other frameworks and libraries. Okay, so the model has already been deployed on AWS SageMaker, and you can find that video in my AI model deployment playlist, okay, where I have shown that how you can deploy a large language model on AWS SageMaker, and also the link will be given in the description. So we are going to utilize that deployed model from SageMaker. We are going to use LangChain to leverage that model that will retrieve some kind of information from your knowledge base. And your knowledge base is nothing but some case studies, some medical reports, some encyclopedias, etc., etc. So if I show you the data that we have considered, in that case, so maybe first let me ask some questions. So if you see, this is how the UI looks like. Pet Care AI, your one-stop solution for your little fur baby. So this is for veterinaries doctor. If you are a doctor who is in the field of veterinaries, this app will be really helpful for you, or you would like to build an application like this. I also have one video that's called medical chatbot, that's more aligned towards human, but this is more aligned toward pets. So let's ask a couple of questions and see how it responds. So my first question is, my dog is always licking her paws and it's becoming red, or something like that. Okay, it's becoming red. Let's hit enter, and you can see this is the question that I have asked, and it's really fast because the model has already been deployed on SageMaker. When you are running it for the first time, it will take little time because the embedding is currently offline, because we haven't deployed that part, but we will also deploy this application in the next video. We're going to deploy this on AWS Fargate, etc. We'll deploy this completely on AWS Stack. Now if you see, this is the question that I asked. My dog is always licking her paw and it's becoming red. So your dog will diminish aggression and subsequent bite downs, supervise due sensation of being brushed, and something like. So it might be allergies, it might be paw injuries, it might be some other, and it also gives you the source document and the page number from which it has retrieved. So I will also show you that documents very soon. Now, so this is one of the questions that I asked, and it retrieved the information related to that question. Now if I ask some other questions as well, for example, let me ask this. So this is like still filly was found collapsed or something. Found collapsed. What's collapsed and what should I do? What should I do now? Okay, what should I do? Let's call it now. Let me see what's this wrong in collapsed. Okay, I'm now asking this question. Slidestal filly was found collapsed, and what should I do now? Okay, so a filly, you can see the response from it. Okay, it says, it also gives you the case, and the answer is not that filtered. Maybe I'll explain that when I'm writing the code. If you see, it says here, it shows here that Slidestal filly was found collapsed in the field day after it seen galloping round with its mother. Analyze support severe myopathy, may involve skeletal and cardiac muscle contributing to the collapse and date of this fall. The severe myopathy is the most likely cause for the based on the results, and it's likely that the fall has severe myopathy, which may involve skeletal and cardiac muscle. Therefore, I would recommend further testing to confirm the diagnosis and rule out other potential causes of this collapse. Okay, the filly which has found collapsed. So you can also, it totally depends what kind of data that you have. So I have taken two big PDFs. One is this veterinary clinical pathology case-based approach. So it has a lot of case studies, and this will really be helpful for veterinary students or even doctors, who wants to go through and retrieve information from multiple case studies. And also I've taken an encyclopedia, and that I will show that. So if I say, okay, now if I ask this question, my dog is always lethargic, sad, and not eating any food. Okay, this is basically happens with our pets, right? They sometimes they feel very sad and lethargic, and they sit somewhere in the corner of the room or somewhere, and they don't eat any food. So what should you do in that case? Something like this, right? And if there's a justification, if there is a scientific justification that how you can take some approach and treat that pet if there is something happening from a health standpoint. So what should I do in that case? And I ask this question, you can see it says, and it's fast also because the model has already been deployed on SageMaker. You can see it takes around 2 to 3 seconds to retrieve the response. It says, nearly all dogs requires 45 minutes of aerobic exercises every day to stay healthy. And for the life of dog to control infection when there is no responses to treatment, your veterinarian may recommend neutering. Your dog is lethargic, sad, and not eating any food. It's important to take them to vet as soon as possible. They will perform a physical examination and run some tests to determine the cause of their symptoms. Depending on the diagnosis, your vet may recommend medication, dietary changes, or other treatments to help your dog feel better. It's important to follow your vet's recommendation, and it have your page number as well, which is around 346. This is encyclopedia, and I will show the data when I'm writing the code. So this is what, and let's ask one more question and see if it's what kind of response we are getting. I'll say my dog is having itching in his ears. If I this question, in his ear, what might be the possible region? What might be the possible regions? Now I ask this question, my dog is having itching in his ear, what might be the possible region? So you can see it, right? Dogs typically hold the painful ear down, tipping their heads, accessing a head scratching may result in ear flap swelling, blah blah blah. Always dry your dog's ears after bathing, and some kind of information. It might be due to some infection, right? You can cotton cause ear infection, etc., etc. It all has been retrieved from that couple of PDFs that we have as a data source, and we are using retrieval chain from LangChain here to build this application. This user interface might look little familiar to you because the UI, I have taken some reference from Hugging Chat. Okay, what was that? What was it? Hugging Chat or Hugging GPT or something? Hugging Chat. So if you open their UI, it might look little similar, right? So it looks similar, and that's what I have taken. But this is built in some JavaScript libraries or framework, but this is built in Bootstrap. So this will be given to you guys, so don't worry about it. So it has a logout and it has a login. So when I click on logout, okay, it takes you to the PetCare AI where you can do login as well. So I just do user and user as a password, which I already have this password. And once you sign in, it takes you to the dashboard or where you can have this search capabilities. That's what we are going to build in this video, guys. A PetCare AI solution or application for vet. So if you are from vet domain or in those areas, if you're working, this will be really helpful. Or even for pet lovers, if you want to take a first aid or caution for your pets, you can deploy this app, because we are also going to deploy that, and you can just use that link, because it's not based on OpenAI or any API keys. It is based on open source stack. We have deployed this model. You can see the model has been deployed here on SageMaker, and you can see this is where we deployed our model on SageMaker in the previous video, and that's the model we are using from the model endpoint, and I'll show you when I'm writing the code. So now let's build this, guys. Let's build this application completely from scratch, and we'll take a little bit of code, but we'll write the code. So let's start building this application now. Okay guys, so to build this application, we need a few things. So let's first see what are the things that we need. So what I'm going to write here is, so let's write PetCare AI chatbot. Okay, and we need a data source in this case. So let me just write that data source. So in our case, it's one case study, which is a vet related case study, and the other is dog care encyclopedia. So I have these two PDFs. You can have n number of PDFs. Okay, the next thing that we need is we have to create vectors, right? Out of this, where we need embeddings, and for that we need a model for embeddings, or for features, by the way, the feature extraction that we have to do. So in that case, we need an embedding model. I'm writing embedding because one of the most used word nowadays, huh? So we are looking at how we can take a RAG approach, for this. So let me just write it: a RAG based approach, retrieval augmented generation. We need an embedding model, and for that, in that case, our embedding model is a multilingual model. We're going to use a multilingual E5 model for this. So let me just write that here. And the reason I'm taking a multilingual model is because you may want to, there are two reasons for it. The first reason is you would have different languages, when you have data source. So suppose one document is in Spanish, the other document is in German, the other document is in Chinese, Mandarin, whatever. You can have different documents and you can use a multilingual embedding model in that case. I don't have that document or data source with me, but you would probably have. Everything will work same. And I will also show you how you can also write your query in Japanese, and it will retrieve the information from that embeddings that you have created on your Japanese document. Just you need to translate that query from Japanese to English before sending it to a large language model, which is Llama 2 in this case. Now you have a multilingual E5 model. There are two reasons for it. The one is multilinguality, which is self-explanatory from the name itself. So multiple languages. So I'm writing multiple language, and the other is the token size, of that words, that embedding that we are creating. So you would have seen chunk size and chunk overlap, right? So when you use sentence transformer, by default this is 128. So also considering we need a better embedding model. I'm not saying that this is a better embedding model when you compare this with sentence transformers, but it provides little higher windows of that chunk size that we are creating. That's why I'm not using sentence transformers, for this one. Then you have, when I say sentence transformer, the mini LM model or MPNet model. Okay, so I'm going with multilingual E5 model here. I'll show you which embedding model that we're gonna use here. So the next is we need an LLM, and in that case our LLM is Llama 2. Okay, so Llama 2 model we're going to use. It's an open source large language model by Meta AI, which has been trained on more than 200 or trillion tokens. Not 200, 2 trillion tokens or something. Okay, it's one of the best model right now when it comes to open source. So this is LLM embedding model, our data source, and then we need a framework that will do all the heavy liftings, to chain together for prompting and all. I'm going to use LangChain here in this case, and I'm going to use LangChain SageMaker class. I'll show you, because our Llama 2 has been deployed on SageMaker, so we have to use LangChain SageMaker class to need that LLM from that model endpoint. Now we have the LLMs, we have the frameworks, we have the embedding model, we have the data source. What we need is the application. We need a backend framework. So in backend, our framework will be Fast API. So we're going to use Fast API by TianGolo, which is one of my favorite framework of all time. So we're going to use Fast API. You can also create APIs, and it also gives you Jinja 2 template, for UI integration. So this is what we're going to do here, guys. And Bootstrap, of course. So I'm writing Bootstrap, Bootstrap version 5.3 or something for UI. So this is what we need. So we have a data source, we have an embedding model, an LLM, a framework, and that's how it is going to happen. So very high level, you have your data source. Now this is your data source, your data. You first create embeddings. Your embeddings are like created in lower dimensional space, a lower dimensional space, latent space. There you have this embedding the relevant chunks. Now this is an offline process entirely, and for that you have the embedding. We store that in a FAS here. For this we are going to use FAS CPU. Let me just write it. So we're going to use FAS CPU here. So let me just write it. So we are going to use FAS, which is again by Facebook. Fast CPU. For embedding we are going to use a multilingual HF model. So let me just write HF, a Hugging Face model for embedding and fast CPU. This is an offline process. Now once user comes in, so once user comes on your app, now this is your app, a query will be passed, a query. So this again, you need an embedding model, same model you need, embedding model that will get the that will create the embeddings of your question that you are asking, and then it goes to that fast CPU. So it goes to that fast. Here again we load that embedding, fast load, and then it looks at the relevant chunks, and then it has a similarity matching, okay, between this embedding, the query embedding, and the embedding that you have created from your document, and the relevant chunk is then passed to LLM that basically generates the response for you, generates the response. This is a high level, very high level architecture. One, you create embeddings and the user comes here. So user on app query something, then it create embedding of that query that you are asking, and then you already have your embeddings for your PDF or the data sources, and then we just do some similarity search or something to find out the relevant chunk out of it, which vectors are similar to the vector that you already have in a vector data store or vector store, and then it pass it to LLM to generate the response. That's what pretty much we do, guys, in this case. So the first thing that I'm going to do here is I'm going to show you my folder repository, the directory. So let me open this in terminal here, and I'm going to activate my Conda Activate LangChain environment, where I have installed all my generative AI related dependencies and library. LangChain, Conda Activate LangChain. I'm just going to open in code dot, and once I opens in code dot, so what I'm going to do in this case is, you can see your HTML file here. I'm not bothered about HTML file because you will get all this, right? So don't have to worry about. So you can see the folder structure. We have data, in that data I'll open data also. The first thing is dog facts, the pet parents A to Z home care encyclopedia, and you can go through the entire PDFs. It has around more than 500 pages into it, and that's the one of the source document that we have, and we're going to create embeddings on top of it. The other one is veterinary clinical pathology case-based approaches, and this is one of the best document I have seen recently, which is very interesting. I was reading it, for I was reading few of the case studies, and I really got good knowledge about the how to solve a problem, or how to approach how to take an approach when the problem is there for a pet. For example, if you see this, a 14-year-old female neutered DSH cat is eating not as well as before, is occasionally vomiting, and has a marked increased body condition score. So they have the hematology for it, and you can see all the scores and some questions on top of it. So now this is a case study, okay, a sample of case study. They have multiple case studies in this document, which has more than 200 pages. So they have multiple case studies, and this will be really helpful for vet, okay, and also the students who are pursuing their career in vet field or vet domain. That will help them retrieve information faster, to understand some terminologies, and how they can solve some problem, or how they can how they can approach to solve a problem when it comes to a pet's health, right, or the animal's health rather. So this is the source document. So let me just close this. You just saw the data. Now you put 2000 documents, depending on, you should have that compute power in your machine. You put n number of case studies, proprietary data, different type of data, and generative AI being one of the most I'll say the most talked technology nowadays, and also most used, I will say. Nowadays people are putting generative AI in everything. Healthcare is an area where I can see a lot of potential. There is a hell lot of potential when it comes to healthcare, and generative AI can really solve complex problems in this field, right? And that's why this is one of the examples, but there can be multiple other examples. So now see, this is how the folder structure looks like. I have a data, and I have an static folder where I will have all my static, like logos, icons, like the pet emojis, etc., and whatever I want to keep it in the static, we're not going to change. That will be in your static folder. and then I have templates folder where I have two files, chat HTML and login HTML. Okay, so in chat HTML, what I basically do is I have that chat interface, and in the login is a login page that I was showing you, and then you have requirements txt that will be given, so don't worry about it. You need some dependencies in the library. The first thing that I'm going to do here is to create an llm.py. Okay, so just to show that how I'm going to utilize that model that I have deployed on SageMaker. So if you come here on the screen, you can see we have deployed a model. Let me go to SageMaker. I already have deployed. Please watch that video. My past two videos you can watch. Okay, just go to AI deployment model playlist and just watch, one of the last video or the second last video, for deployment. And you can see if you come to inference here, you have an endpoint, and in this endpoint, this is the endpoint that I'm going to use, to make the LLM call there, the LLM model load. So we're going to use this model which has been deployed. Okay, and it's a 7B model. You can deploy a 13B model or 70B model as well, depending on what machine you have. So I have G5 2x large, and that's why I have deployed 7B model. You can take G5 4x large to deploy a 13B model. I'll go a little quick and I'll just show how we can utilize that model first, and then we'll start writing code for embeddings and all. The first thing I'm going to do is import Boto3, import JSON. You need Boto3 to be in your machine if you are using the same deployed model or any model that you have on AWS. Okay, SageMaker, by the way. The next thing that we have to do to put the bring the endpoint name, so endpoint name, and we're going to define that endpoint name. So let's just copy this endpoint name here, control C, control V, and after this endpoint name we are going to write an LLM function that will take payload as input parameter, and within this payload we're going to write a client where we have boto3.client, boto3.client, and we're going to use something called runtime.sagemaker that I also used when I was writing the lambda function. And you also have to write location, not location, it's region name for AWS, and a region name US East 1. So when you are doing it, you have to do it in an environment file. By the way, I'm just showing it because I will delete that endpoint after this video. So because these are confidential information, you would not like to show it upfront, you have to keep this an env file. Now response, and then we are going to use client.invoke_endpoint to invoke that endpoint, just to send you a prompt to retrieve some kind of information. Then endpoint name, and that endpoint name is your endpoint name that you have written on top. It also looks for some kind of content type. Make sure your first letter is capital and the next coming letters is also capital, the next attached word, which is type in this case. So T will be capital, so it's little case sensitive. Then you have to pass application JSON, and then you also have to write excuse me, Alt G. Then you also have to write body, and body gonna be just json.dumps, and just pass that payload. Okay, so payload, and just you have to do return response. That's it, we are done with this function, guys. And the next is your prompt. So let's write a prompt, and my prompt is nothing but what is blockchain. Okay, now for example, if this is what I want to ask this LLM, what is blockchain, now this is my prompt. Let's take this payload. So what I'm going to do here is I'm going to go inside this deployment, it's fine, server connection, whatever. I'm just going to click on payload and come here, paste it over here. My prompt is what is blockchain in this case, and you can look at the maximum tokens, repetition penalty. I have explained this, I'm not going to explain the same thing. You should watch my previous videos, to be honest. And then the next thing that we're going to do is result, and result is nothing but I'm just going to use that function that I have defined on top, load LLM, and just pass this payload. So I'm just going to pass this payload here, or let's just write payload. And you have to read, you need the body of this, right? So you have also done it here. You can see this is how we have done it, response 0 generated text, and this is what we have to do in this case as well. So now let's do that, guys. So here what I'm going to do is just to do your let's define a new variable called final result, and this final result is result and then your body, and that's what we are going to do here. And just we have to read this now because it will give you a object, so we have to read that. So print and then final result dot read. Okay, so let's just read it. So I'm just reading it here, guys. Okay, final result. And now let's open this terminal and just run python llm.py, and you can see. So what I have done here in this case, I have imported the required dependencies to connect with the AWS, which is Boto3 Python client. Then we have JSON, your endpoint name, your model, deployed model endpoint name. Then we write a simple function, pass the prompt. Right now we're passing the prompt here, but when we have the UI or the application, we'll pass that through input box that we have right on the front end. And then your payload and result and something like that. Okay. Now you see this is the response we got. Fantastic. What is blockchain? Blockchain is a distributed digital ledger that records transactions, blah blah blah. This is what we got. Now fantastic. This is the reason I am showing you, because if you have deployed your large language model on AWS SageMaker, this is a file you need, if you just want to test it out locally in your machine. Okay, now let's create a file called ingest.py, which is I'm going to copy it from my GitHub repository, because I have done this ingest in all of my videos. There's many applications. If you want to create applications and projects, watch my LLM playlist. Whatever you want to do, chat with audio, chat with video, chat with PDF, chat with GitHub, chat with websites, everything is there. Okay, now if you come to ingest.py, now let's go inside AI Anytime Llama 2, which is a medical chatbot, which is the previous video you can see for humans. Now this is for pet that we are building, or mainly for the vet doctors, people who are working in the domain of veterinaries. Okay, so now let me just paste it over here. Now if you see in this case what we are doing in ingest.py, we have to create the embeddings, guys, right? So what we are doing, we are importing that some of the modules that will help us create that embedding. So first you have to load the file. For that you need a pre-processing module or to something to pre-process your data, and that's what we are doing with LangChain PyPDF loader, because we have PDF files and all those files are in a directory that's called data. That's why you have to load directory loader. You can also do unstructured. If you have here, you can see the loader class PyPDF loader. But what if you have different type of data formats, and this is a little tricky, so you have to spend some time on directory loader and how you're loading it from directory. If you have a text file, that will not be PyPDF. You have to look at the text in that case. Then you have to unstructured, then you have CSV loaders. So different type of module we have in LangChain, and you have to use that accordingly. What I'm doing in the line number 6 is I'm giving my data path, and I'm also saying, okay, whatever embeddings you are creating, save that in an in-memory vector store. Okay, I'm not using a vector database here, it's a vector store. You want to use Pinecone, or you want to use any other, go ahead and use it. You can also use it Qdrant. If you want an open source vector database, you can use Qdrant. You can also use Viviette if you want, depending on that. But just to keep it simple, in line number 7, I'm saying to this program that, okay, if you are creating a vector store, create a directory called vector store, create a directory called dbfast, keep everything inside it, and that will automatically happen. Then I'm writing something. Let me just make some changes here, guys. It's a vector store. Okay, now you have a create vector dv function that has a loader that loads the files from that directory, data directory, and then split that on a chunk size of 500, chunk overlap of 50, and then we split that, and then we use a model. So as I said that we are not going to use this model, so we are going to use some other model in this case. And if you see, in this model we are using sentence transformers mini language model, mini LM-L6 v2, but for this I'm going to change this model. I'm going to use multilingual E5 large, okay, which you should try that model if you have different or multiple language. Okay, so it's by int float. So I'm writing int float multilingual. It's on Hugging Face. You can just let me see what's the name of that. Okay, multilingual E5 or something. So multilingual E5 large, Hugging Face. This is what we need. Okay, so let me just copy it from here to avoid some typo or spelling mistake. And I'll just come over here and I'm passing that in model name. Okay, now this is the embedding model I'm going to use in this video for this application. And then you have model quarks, which is on CPU. If you have CUDA, you just pass CUDA here to make it a little faster, but I'm okay with it because I only have 2 files. Now then we have DV, and say, okay, fetch from document all of your text, which is in a list kind of a thing. Then you have embeddings, and that embeddings model that you have, and then save local. So save that in that dv fast path. So let me run this, guys, because now this is going to take a few minutes. I will pause this video. So how we're going to run this is, If you have some other name of your data path, then you have to change that file data path name there. Okay, suppose for example, if you have sample data, that will become sample data. Okay, so please make sure that if you are using the same code, make sure to change according to the terminologies that you have for your data source and all. Now here what I'm going to do, I'm just going to run this as python ingest.py. So when I run python ingest.py, it will take a few minutes. It might take up to 10 minutes because the PDFs are a little big. So what I'm going to do, I'm going to pause that video, and once the folders are created, I will resume the video from there, guys. Okay, so now you guys can see that we have a vector store which has been created over here. And if you click on this vector store, you can see two files within db-faz folder, which called index.faz and then index.pkl, which is a pickle file, the serialized files, guys. Okay, now if you see, this is the ingest.py we created on our document. We have now our embeddings done, completed, and it's in memory, by the way, so make sure that it's not too big, otherwise it will crash your machine. So depending on that, you will better use a vector database in that case. Now what I'm going to do here in this case is, now let's create an app.py where we'll write the code logic for our the backend that we're going to create here, for that front end that we already have in templates folder. So if you see the templates, which has chat HTML and a login HTML page. Now what I'm going to do inside this app is, I'm not going to write a hell lot of code because it's too duplicated. So in most of my previous videos, I'm using almost the same code, but here I'm going to make few changes. Let me first show you what I'm going to do. So I'm going to use a LangChain SageMaker class. So let me just click on LangChain SageMaker. I'm not going to write class here. Okay, just write LangChain SageMaker, and you can look at their SageMaker endpoint. Okay, this is just for your information. This document, LangChain is having good documentation. I'll not say the greatest of documentations, but the documentation is good enough to at least work with. And they have shown here that how you can leverage the SageMaker endpoint. So the model endpoint that we have, how you can utilize that through LangChain. Okay, so they have SageMaker endpoint. They also have LLM content handler. In that content handler, you can pass your basically the model quarks, the prompts, how the instruction prompt would look like, and a lot of other things in that content handler. And then you have different chains that you can use it, of course. So I'm just showing you. I'll give this link in the description for their documentation. You can read about it. So what I'm going to do now, I'm going to go on my AI Anytime GitHub. Excuse me. AI Anytime GitHub, and I'm going to take I'll go inside the model gist, and inside that I'm going to copy few of the gist like imports and some duplicated functions that it's already available everywhere. So I'll just explain that how are we doing it. Now on the gist, if you see on gist, the first thing that we need is the imports. So let's import everything that we need. So here for that, I'm just going to import this, come over here in this app.py and just going to paste it. So what I'm doing here, I'm using FastAPI by TNGolo, which is FastAPI is a framework, Python framework, extremely fast, powerful, and also really pleased to work with FastAPI. And you can see it has Jinja 2 templates that help you integrate your backend with the HTML UI, etc. Then you have the Jinja 2 template. Then I'm using static files, and then I have some encoders, just enable encoder for output parsing and all. Then we have we're also using crypt context mainly for password hashing and all. That we'll have a login page that I'm gonna show you. And then we have session middleware something. Then we have UVCon, which is a web server that helps you, that fuels your FastAPI application to run that. Then we have LangChain thingy. So I'm going to use SageMaker endpoint module from LangChain, as I said. Then I'm going to use a prompt template probably. And then I have LLM content handler, streaming. Maybe if you want streaming responses, I'm not doing in this video, but maybe you can do that. And then you have retrieval QA and Hugging Face embeddings and fast. So now let's do that. By the way, there's no direct streaming function, at least for Llama or open source model with LangChain. It supports for Cohere and Cloud and GPT, all closed source model it supports. but I'm not sure about open source streaming responses with LangChain. But there are workarounds for that, guys. Now what I'm going to do here is I'm going to first define my region. So my region is nothing but US East 1 for this app, and then we need endpoint name. So let's define that endpoint name. So let me just copy it from LLM Pi here. So this is my endpoint name, Control C, and just gonna paste here, Control V. This is my endpoint name. Now this is okay. Now I'm going to use templates as a variable. We're gonna pass Jinja 2 templates thingy. In Jinja 2, you just pass your directory. So my directory name is just templates. So I'm just gonna pass templates, and so templates, and I'm going to mount the app. So app.mount. So let's do that. And by the way, you have to first define an app. I forgot to define that app. So you have to initialize a fast API application, and this is how you do it. Fast API, you would have worked with Flask. You might have done the similar thing with Flask also. Now here what we have to do, and we also need that vector store path as well. So let's use that quickly. Control C, come over here and paste it after this, because we need this for retrieval chain. You can also use conversational retrieval chain, guys, if you want to use that. App.mount, and within this app.mount, I'm gonna pass my static thingy. So it's called static, and in that static, I'm going to use static file, yes, that we have static files, and I'm going to pass my directory, and my directory is nothing but static. So static is my directory, and inside this I'm going to pass my name. So name equals, and then it goes static. Okay, so this is now mounting thingy. And I also need, if you want to enable some session management, you can also do with middleware, or there are a lot of features that you can explore when it comes to fast API. So add middleware. Let's have a session middleware. Exactly. So session middleware, and then I'm going to pass a secret key. In production you will pass some secret key there, but I'm just keep it nothing here. So let me just write something like this, and just write your secret key. Okay, but in production you will do it little differently, guys. Okay, don't do the same thing. Now let's simulate a database, because I'm not going to create a database here like a Supabase or Postgres based on that or something like that. I'm just going to create a fake simulation of how the database would look like. Okay, so let's create something called fake users DB, which is going to be an empty list by now. So this is my fake users DB, and then I'm going to use that class. Okay, so I'm going to use a class that I'm going to show you. I'm going to explain that user class. Now let's just copy this user class. So what I am doing here, I'll just explain that to you quickly. Now in this class, what we are doing, we first initializing. So we have diff init, a function that takes username and hashed password, which are string, of course, and then you have your username and password, and that's why we're using crypt context. Okay, so password hashing configuration, so bcrypt. Okay, and that basically hash your password, and you can see the password that currently I'm setting it from backend, but this is not how it will happen, by the way. Okay, so you have two users now in this application. So I have created two users for line number 43 and 44. You have the password user 1 and then password user 2, and then just hashing the password like admin @123, user @123. We are hashing both the password, and then we creating simple sample users. Okay, admin and user, the two users, and then passing the hash word password user 1, password user 2. Simple programming, guys, simple Pythonic thing. And then we have verify password, which is your plain password, and then hash password. Okay, so this is how you're gonna verify the password when you put it on the UI screen, right? And then just get the user self-explanatory, that this will get the user from that list, that the database that we have created, the fake users database. Now this is pretty much on the database thingy. Now what I'm going to do here is I'm going to write some code for build chain. We have other gist also that we're going to utilize it, but we'll utilize that later, guys. So first what I'm going to do here is I'm going to now write code for the main thing that we have, the LLM thing. So let's write it. So I'm going to create a function called build chain. So let's create that function, and in the build chain, the first thing that we need is embedding. So let's copy that embeddings part from here. So let's just do embeddings, come over here in app.py, and let's just paste here. So now you see we have embeddings. So same thing that we have been using in ingest.py, because now once user asks a query, you have to create embeddings of that as well. Okay, so embeddings, and now the next thing that we have to do is we have to load that FAS, that vector store that we have. So FAS dot load local, so we have saved it locally, so we're going to use load local. I'm going to give that path that we have defined on top, if you see it over here, which is on line number 22. So let's do that, dv fast path, and then we'll also pass this embeddings variable that holds our model thingy embedding. That's it. So now we are okay with embedding. So now we have to write a content handler class that is going to basically leverage your LLM from SageMaker. Okay, so now let's do that. So basically customize the content handler, to handle the inputs and output to the SageMaker endpoint. So let's do that. So I'm going to do class, and I'm going to write content handler, and it looks for an object. So our object is nothing, so let's write an object, and this object is going to be LLM content handler. Exactly, so this is right. So LLM content handler, and then it looks for content type, as we already know, which is application JSON. So let's write that, application, and then you write JSON/JSON. This is how I have shown in the notebook as well on SageMaker, and then it also accepts. So accepts application JSON as well. Fantastic. This is what we have to do. We are okay. I don't know why it's a bracket there. Okay, now accepts. Now so we're going to write two functions inside this class. One is transform input and the other is transform output. Simple. So let's write a class quickly called transform underscore input. We look for self, and then we give prompt. Okay, prompt, and you can also define that data structure. You have to define that structure, that how it's going to your data is going to look like, and what is the input type of that data. So in that case, which is string for me in this prompt, and now prompt is the string. Then you have your model quarks, like you can pass your payload, and that payload can contain temperature and penalties, all the hyperparameter, not hyperparameter, it's inference parameters that you can pass there. Hyperparameter when you are training it. So the inference parameters, so the model quarks, and model quarks, again, very Pythonic, it's dictionary, it's a key value pair. So you have to write dict there in that case. Fantastic. So we have this function. Okay, and let's also, write, also not close it for now, let's write byte. So we also define that here. Exactly, bytes. Now here we can write our function for transform inputs. Okay, transform input. Now we have to write the payload. So let's take the payload from LLM Pi. Okay, we don't have to reinvent the wheel by writing all the lines, right? So let's just copy the payload, come here on the app.py, and just paste it over there. Okay, so now let me just have this payload, and I'm just going to basically, okay, and this will come the indentation. Okay, and then we have the payload, so this will also come here. Okay, and this looks nice. Okay, so def build, and let me just, excuse me. Okay, so def transform, and this looks nice. We have this transform input, and then after this input, now what I'm going to do here is I'm going to write and the indentation are not correct, so let me just look at this again. Now this will, the payload, let me see if this is at the right place. Okay, let me just close it here, and what I'm going to do here now is I'm going to write my input string. So my input string, and I'm going to dump this inside json.dumps. So let's just use json.dumps and use payload. This is how we're going to write the input string, and I'm just going to return this. So let's return this input string, and then we have to, otherwise it will give you deserialization input error. So input string dot, we have to encode this with UTF-8, I guess. Yes. Okay, Now this is your transform input function, which takes a payload and inputs prompt, and then has your parameters which looks good. So json.dumps payload, and now what I'm going to do now next is I'm going to write a same function for transforming the output. So let's do that as well. So in that case, let's copy this, or let's quickly write it, transform output, and in this transform output also we're gonna have self. So let's write self, and then we're gonna have output. So in output and just bytes, and this will have your as this should be string. Okay, this should be string. So transform output, and the first thing that we're gonna have is response. So let's call it response JSON, and in this JSON I'm going to use yes, but you have to read that because it gives you an object. So let output dot read, JSON dot loads output dot read, and then we also decode. We have to decode that as we have encoded on top, so it has to decode by UTF-8 again. So it's a function decode UTF-8. Now the transform output, and then just have, we need that, we have to pass that output, right? So let's write content response JSON, and then I only need generated text out of it. That's what I have shown on my SageMaker notebook as well. So generated text, that's it. So now content response JSON transform, this looks nice. Now we have to create an LLM chain, inside this build chain. So let's create a not the chain. Now we have to create use the SageMaker endpoint now. So let's use that SageMaker endpoint. It's not manager, let's just use SageMaker endpoint, and the first thing that I'm going to use is endpoint and my endpoint name. So let's just use endpoint name. So my endpoint name is endpoint name. Okay, now this is done. The next is region name. So let's use region name. So region name is region name, and then content handler that we have on top. So content handler, and then I have a content handler in that case. So let's use that content handler. Okay, so what else we need? We need some callback. So let's use that streaming callback handler, right? So callbacks, and it goes inside a list. So streaming call, yes, fantastic, and this is a function. So let's use that, and then here will be, and then if you are using a Llama 2 model, deployed Llama 2, then what you have to also use, you have to give that EULA accept EULA certification, whatever that they have, right? So that's in documentation, guys. So endpoint quarks, and endpoint quarks is going to be your custom attribute. So let's write custom attributes, and this is nothing but quark should be dictionary, so it's wrong. So let me make this a key value pairs. In this custom attributes, we're gonna write we accept EULA, which is accept underscore EULA, which is true in this case, accept EULA, which is true. Okay, now this is your, and I have to end that, by the way. Okay, to close that. Now your LLM SageMaker endpoint is also done. Now what you have to do is you have to now write a chain using LangChain. So let's call it QA, and in this QA I'm going to use retrieval QA chain. So retrieval QA chain, and not from chain type, and inside this I'm going to write LLM. So my LLM is LLM that we have written on top. You can see from the SageMaker endpoint, that becomes your LLM, and then you have retriever. Let's define a, excuse me, so let's define that function called retriever, and inside this retriever it's going to be db.asRetriever. So in this db.asRetriever I'm going to have a search quarks. So search quarks is going to be my k equals 2. So let's have, excuse me, this is a key value pair again, k becomes 2. Okay, and then just return source documents true. I need the source document that you are showing on the front end. So return source documents, I spelled it wrong, return dot source document, which is true, and that's it. We are okay with our chain, guys. So just let's return this QA here. So return QA, fantastic. Now what I'm going to do here is, so let me just explain build chain what we are doing. So we have, using our embeddings, we have loaded the embeddings, we have written a content handler that has an object called LLM content handler. We define what kind of content we are expecting and what is going to be look like, so it's a JSON. Then we have two functions. In one function we are configuring all of our payloads, all the inference parameters, and the other function we have a transform output. So in one we are encoding it, and the other we are decoding it and just presenting the generated text response, okay, from Llama 2 response. Okay, that's how Llama 2 responds, guys. So now you're okay with it. Let's write one more function that's going to run this chain. So let's make it modular so you can use it separately wherever you want the functions. Now here I'm going to write chain and just going to write prompt, and it's going to be string, so you can define that. You can also ignore it, by the way. Okay, so run chain and just return chain. So return chain, and it's going to have a key value pair. Let's have a query. Fantastic. Query prompt, that's it. Okay, so run chain, and then we use this chain. So let's call it build chain, the function that we have used on top. Now so far we have written all the code that we need for LLM, guys. Okay, this will help you retrieve the response from your knowledge base using a large language model called Llama 2, but we need to process that answer because it gives you a lot of metadata. Okay, helpful answer, unhelpful answer, and for that I have created a function that I'm going to use. I'm not going to write that. You can see the process answer, and I will give all this link in description, guys. You can use it. So process answer. So let's come over here and just paste. So I'm just going to paste it. This is my process answer. So I'm just splitting the answer, okay, the helpful answer wherever required, the question, and just only return the final answer so it looks nice to you. Okay, and you can play around it because this is again depend how you want to customize your answer based on your source document, etc., etc. That's it, guys. So now what I'm going to do now, I'm going to write couple of functions. I'm going to use couple of functions from my GitHub gist. This is the code that you need basically to run this application from backend. Now we need that backend framework which is going to utilize this through a API or something, right? An API endpoint, okay, in Python. So for that I'm going to use my let's use fast API functions that has all of the functions that we need. So I'm just going to basically copy this. So let me just copy this entire functions. And I explain that function what we are doing, just if you don't have much expertise with fast API or even Python. So what we are doing here, if you see the first thing, we have a login route. All are these decorators. So if you see this app.post, we are making a post request. We are sending our data, and that is nothing but your username and password, right? You are inputting that in your input box on the UI. So we need a method to basically respond to that or to connect with your API endpoint. And if in this case it is login, and we are making a post request to this login API endpoint, which has an asynchronous function. That's one of the reasons that we use fast API, which gives you the async functionalities. You can run the functions asynchronously, multiple functions. Now you have this async defined login, which has a request, which has a username as a password as an input data type or a parameter with the data type defined already. Then you use this function called get username that holds your username thingy there. Then you are verifying the password, returning some exception. You are having some exception handling. If you are getting any error like sorry, it's a wrong password or something, we just return that. We are storing information in a session and just redirecting to a protected page. You can see it's all has been commented over here. It's a successful login. It takes you to that search UI. Okay, you can search or you can interact with it. Then it also has a logout route, pretty much self-explanatory, where just write a function to log out from that application. So you can see just popping out the session, because the session is a list, by the way. In this case it holds your user information, and just pop out that. So when you delete that information, just logs out. Okay, now what we are doing here in this case, we are writing one more function that's called define chat. This is a chat. It's a protected endpoint. For at least from login it goes here. So after login it goes here inside this. Now you can see it says check if user is logged in, line number 152, which is important. Now if it logs in, it takes you to that page where you can make some query or you can retrieve some kind of information. Now in that case, redirect to login if not logged in. So if you're not logged in, it will redirect to you, and if you are successfully logging in, it will succeed through and it will go to chat.html page. So we already have this chat.html here in the templates. You can see it over here, the chat.html. And then we have app.get root route that basically looks at that login HTML. There's a login page. You can write it on top, by the way, and this is your final endpoint, and this is everything, by the way. This is called chat_response. This is the USP, right? This is your backbone of this entire application. Now what it does, it uses a function called run chain. It utilizes that run chain function. It is passing the chain equals chain and prompt equals prompt. Prompt is coming from the end user's input that you are inputting. Then uses that process answer function to beautify the response and just returns with the source document, just looking at the metadata, the page number and all, and just appending that in a list or something, and just responding that through a JSON response. You can see it over here, and just return that on response data, which is on an HTML page. That's what this function does, guys. Pretty much self-explanatory. And then we are saying, okay, you just use this Uvicon server to run this application on port 8000, and you can keep reload equals to true. So when you're making some changes in the backend, the py file, it will automatically reflect on the UI screen as well, all the changes, and you can do that in the Windows or wherever you possible. Okay, so this is what it's doing, guys. We are done with our application now. Now let's run this and see what kind of response we are getting, from this application. Are we getting any error or something like that? So let's now check it out. So to run this, guys, what you have to do now, to go back to your terminal, and in that terminal you can see I am inside my Conda LangChain environment. So I already have activated this environment. So what I'm going to do now is just run this using Python, app.py or something. So that's what I'm going to do. So let's do Python app.py and see if we are getting any error from it. So when you are running it for the first time, it will take time to load that embeddings, because the embeddings currently running on offline on a CPU machine. But in the next video, we are going to deploy this application completely on AWS using AWS Fargate. Okay, that's what we are going to do in the next video, guys. We're going to deploy this FastAPI application through an a Docker container and stuff. And that's why we're going to use AWS Fargate, Docker, and that too serverless. Fantastic, right? And you can now see application is startup complete. So now let's go back on your UI, and in that case what I'm going to do here is, let me just close all this. We don't need it. Okay, so I'll just close it because I already have shown you, and I'll give you the link in description, of course, for whatever you need. And now you can see, so let me first log out. Okay, so when I log out, because my session was already active, now once I log out, you can see the PetCare AI. It shows a simple UI, and the reason I'm showing you that you can build your own product and services. You can build applications. Of course, this is not production ready by any means, but you can now take this as a base point, as a reference point, and you can now go ahead and scale this up further. Trust me, it's easy to do that. Okay, you go on cloud, deploy it, create your own machine and infrastructure wherever possible, see what's your budget and all, and you create a product, deploy it there, and start rolling it out to the people that you have, right? So if you see this PetCare AI, one of the use cases, for veterinaries, but you can take it in any other industries and domains as well. Now here in the user, what I'm going to do, I'm just going to write user and my password that I have, and it takes me to this, the search where I can, do all the search, guys. Fantastic, right? So now here you can see we have taken the reference from Hugging Chat. Okay, the Hugging Chat that we have earlier I was showing you in the beginning of this video, the UI reference, because it looks nice. Now here you can do a streaming response. You can look at the workaround with the LangChain and Llama 2 and come with a streaming response, and you can basically do it over here. Now what I'm going to do, I'm going to ask a question, like for the same question, if you ask my dog is having itching in his ear, what can be the possible ways to treat? What can be the possible ways? Not let's ask region. What can be the possible regions for it? Now, once I ask this question, the first time when you are asking this question, because it has to, look at the embeddings model and give it to you. Now you can see the cotton can cause ear infection. The cotton that you have. Always dry your dog's ears after bathing with an even bloody if its dog has scratched them. Dogs typically hold the painful ear down, tipping their heads. Excessive shaking or scratching may result in ear flap swelling. See hematology. A bad odor from the ear indicates infection, as does any sort of discourages or discharges, whatever. So you can of course beautify this output parsing. How are you parsing this output? And also you can make it streaming. So the document that I'm going to show you, this is the data that we have used. So let's come back over here, and you can see this is the case study data that we have. But if you see, this comes, let me just go back to the UI. This comes from your encyclopedia, that. But let's come back here, and let me open this veterinary clinical, and we'll ask some questions related to that. So I had that slide, the question that I asked, right? So I'm going to ask the same question and see where the response is coming from that. Okay, so let's now ask the question. I don't know how to pronunciate this, guys, but Clydesdale filly was found to be ruptured or found to be collapsed. How to, or what to do now? Okay, what should I do now? Now this is my next question that I'm asking. Okay, Clydesdale filly was found to be collapsed. It's a filly that has now collapsed, and what should we do now? So if you see, it says page number 16 from this document. Now let's go to this document and look at the page 17. You don't have to look at 16 because the first page I don't think that, or let's see 16, 17, whatever. You can see this now. So the same question. The reason I'm showing you because I asked this question already earlier, and the reason I'm showing you because I remember this question. So Clydesdale filly was found collapsed in the field. Now what should we do now? And you can find out the response and the page number and that response from there. And of course, few of you will ask that how to restrict this to only return the document from this question. So if I ask who is Bill Gates, probably it will respond because it has that base knowledge, and so trust me, the entire industry wants to solve it when it comes to open source LLMs. Okay, but in that case, so let's come back here and see. So this is the document that we have used for in that case. Okay, so if you let's come back here and ask some other questions. Okay, limp in the right. So if I just ask about this case study, beagle present with a limp in right few hours after playing in the garden with another dog, present with a limp in his, let me just ask, copy this, and here what I'm going to do, okay, beagle presents with a limp in his right hind limb. Okay, give me some findings. Let's see if it's able to respond. Give me some findings related to it. I'm asking this question. Okay, and see if it responds to that. Okay, so most of the time it responds the right. There are few hallucinations that I have seen with this, and of course we trying to limit that hallucination with that. And now you can see it says, and it got it right, guys. An 8-year-old male beagle present with a limp in his right. Few are fantastic, right? It's able to retrieve the response from that, from the document that we have with the exact. You can see the page 79, which is 78 in this case, because first one is index or something that we start from 0 or something, right? When you write the code. So this is fantastic. Okay, and getting the responses from it related to the case studies. Now you have your medical reports, your patient reports, which are in different languages. Now how you can build this kind of application where you can ask or retrieve some kind of questions which are very domain specific, which are very RAG based approach, your retrieval augmented generation based approach, how you can build this. This is the reason I wanted to create this video. Now if you log out from this, it takes you to the login screen again. Very simple authentication. Now you can put a payment gateway behind it. You have a simple proprietary startup or a proprietary company or a private limited, you have a payment gateway. Just put a payment gateway or PayPal link behind it and start rolling out after some validation checks and all. You can put guardrails etc on top of it. But this is what I wanted to show in this video, guys. Because few of you guys said the Chainlit app is not responding, it's slow and all, and the reason I shown you can deploy your LLM in your region on AWS and start invoking the endpoint from there. You can create your knowledge base which is still locally, and we are going to deploy this in the next video, guys. That's all. If you like the content, please hit the like icon, share the video with your friends and peer guys, and if you have any thoughts, comment or feedback, please let me know. Please reach out to me if you have any kind of queries. That's all for this video, guys. Thank you so much for watching. See you in the next one.